Hey everybody, Tom Cherryholmes here with the FujiNet project, and I wanted to do a little video here showing how I added two commands to the R device, specifically the Wi-Fi modem, in order to facilitate clients connecting to them so that you could, in the future, use BBS packages. Now, I've made a demonstration of the BBS functionality before, showing that you could run a copy of BBS Express. But now that we're moving all of this functionality over to the Platform I/O code, it's important to take and make sure that this functionality is robust enough to handle for day-to-day use. Starting off, we actually have here two files open, one of which is the modem code and the other, one of which is the header file for the modem code and the other which is the implementation for the modem code. Inside the header file we have two commands that have been added for listen and unlisten. These correspond to SIO commands L and M, or for C and for D. And these commands can be issued at any point to either specify that the FujiNet should listen for TCP connections on a given port, or to stop doing that, conversely, the mirror of that function. The implementation is simple enough. The first thing we make sure is that we process these individual commands themselves. And you can see right here, primarily, here they are ready to go. And you can see that they wind up here. And we can see, as part of SIO listen here, the first thing we check is we see if there's already a listening port already happening. Listen port is defined inside of the object, and if we actually go to it, we can see that we need to listen on this port if set, otherwise 0 to disable. We check to see if this is already set, and if it is, we go ahead and close out the port. Then we take and determine the new listen port based on the parameters that we need to pass through. Now, since this is a simple enough command and all we need is a single 16-bit value, it's very convenient to pass the parameter of this command in the aux1 and aux2 parts of the command frame. So we take and break apart aux1 and aux2, turning it into a 16-bit value here. And then we determine if, for whatever reason, this is an invalid value for this listen port. Since we're using an unsigned, basically an unsigned short for this listen port here, we pretty much determine if it's less than 1 or greater than 65535. And in fact, we should actually take and make a slight modification here. To indicate that this needs to be unsigned short. What's going on here? Why are you mad about that one? Okay, go figure. Real-time compiling, you gotta love it. We check and make sure that this is a valid value of some sort, and if it is, then we check to make sure that it's a valid value. If it's not, we go ahead and do a NAC. Otherwise, we do an ACK here. Then we immediately start up the listen port here for TCP server, which will do all of the work. This is an Arduino class that will do all of the work for us, opening up a TCP connection that can accept connections at a specific listening port. And finally, since we're not having to deal with any data payloads of any side from any direction, we can simply complete the command and indicate to the computer that the command was successful. Now, there is no error handling here because begin, if you notice, begin doesn't return anything. It literally does not return anything, and we can't determine after the fact whether or not the listen was actually successful. Otherwise, there would be a block here to determine whether or not the command, if the command was successful or not, and do a complete or an error. Conversely, the unlisten command is the inverse of this. Since there's only one code path here, we simply acknowledge the command, we close the connection, and we issue a complete as quickly as we can. And that's all we have to do to implement the needed bits and pieces here. And in fact, I'm going to make one slight adjustment here to SIO process to not go ahead and acknowledge off the bat here, but rather to pass into here. And actually, I'm going to go through here and start auditing some of this to make sure that this is all correct. So check the command, listen, unlisten, call it out, ready to go. And that's everything that we need on the ESP side of things. We'll go ahead and save this out. It's been modified, and the same thing here. It's been modified here. We'll go ahead and compile it at this point and upload it to my device. You can see as part of the build process here, it's running a copy of source graph that's basically showing me the dependencies of each bit as it comes in. Only the bits and pieces that we need to compile are actually compiled here, which is very nice compared to Arduino, which compiles everything every single time. Much faster turnaround. Then we see that it's uploading the firmware into my device, and with that, we are now officially ready to go. The hardware is now waiting for me to deal with it. Now at this point, what else do we need to do? Well, we need to write the Atari side of it. And in the repository, on the Atari side of things, we see that we have the Atari Wi-Fi repo, and there's a directory called FNC Tools. And inside FNC Tools, we see a whole stack of individual utilities for individual pieces of FujiNet functionality. Everything from viewing the network configuration to ejecting disks from device slots, setting host slots, listing the device slots, host slots, and the files on a particular TNFS host, mounting everything, mounting a specific ATR image to a host, to a device slot, setting SSID and SSID password, and other bits and pieces. fnew for creating disks, fscan, etc. Now if we actually go in a bit further, we'll see that a couple of things have been added. Namely, we now have commands for what are called rlisten and rulisten, which correspond to the listen commands that we added in the firmware here, and the unlisten commands that have also been added in the firmware. So, if we go into one of them, let's take a look at rlisten, for example. You can literally take the scaffold for any one of these commands, bring it in here, and modify quickly for your particular use. And in fact, most of the time all you need to do is change the program name in the make file and the map file that gets created. This is an optional step, but it's a nice one because it shows you the resulting map of where everything is put into memory, since this is literally being absolutely linked. There's nothing that says this tool has to be written in C. I'm only doing this for the sake of demonstration. You could write this in BASIC, you could write this in Action, you could write it in Pascal, you could write it in Forth. Does not matter. Hopefully the bits and pieces that I'm showing here will prove useful. If we actually look at main.c, we can see our little preambles here, and this is the part that actually does the work. To set the listening port, since this command literally has no payload, this is all it needs. Pick the device, 050, which is the R device, unit number 1, again 50. The command L, the command we defined. dstat-s, which determines whether data is going from the computer to the peripheral, back again, or there is no data transfer taking place. Since 0 is set, no data transfer is taking place. We can then take and say, since no data transfer is taking place, debuff can be null. And we can set this timeout to be whatever we want. This is a fairly quick command, so I set it to 1 second. No bytes are sent in the payload, so this is 0. And finally, the desired port number is sent over in deaux, which we pick up in the opposite side of the firmware. And in fact, if we go back real quick, we can actually see, again, we wind up with deaux over there, which translates literally into, excuse me, if we go into listen, we can see it, which translates into our aux1 and aux2 values here. Quite literally. So moving back, we come back here. Let me go back to this particular window here. And once this is done, we call SIOV to do the call. We check the return value, and if it's anything other than 1, we say it's an error. Return the values. Now, there are a couple of other little bits and pieces here. You'll see in the main, we go ahead and set the left margin to 2 so that it matches up with other utilities. CC65 sets this to 0 as part of the C runtime, and we set this back so it doesn't look obnoxious. We check to see if this is a command line DOS. This is a function that you can use in CC65, which does a whole series of small checks to see which DOS we're running under and whether or not it can take command line parameters. If it does, great. We check the argument count, and if they don't match up, then we take and show our options here. Since we need 1 parameter, we need to check for 2, because the first parameter is not a parameter at all, but actually the name of the file. Return a 1 to indicate that things didn't go so well. Otherwise, we assume we're in MyDOS, and we do an interactive session. Say, okay, what port we want to listen to. And we use a set of functions here, which I've put together, which just call CIO directly. So to make it really nice and tight and easy. And if you actually look in con.io, you'll see these functions. Not much to them. Set up the IOCB, set up the command, the buffer length, and then call CIOV. And we literally get our answer back because CIO puts it right into the buffer that we're looking for. Pretty easy. We can then take and try and convert that to an integer, get that ready. Again, if that value is somehow illegal, then we go ahead and say it's illegal, return. Otherwise, we call our listen port. And we do this as a convenience. If you're running on any DOS that's not a command line DOS, we say press return to continue. Kind of gives you a moment to catch your breath, and you press return, and then we return from the program. That's all we have to do. Conversely, the unlisten program is much the same. You can see it's much the same. The difference being that we have the M command, and we don't care what the other parameters are. I cut and pasted this over. So main just goes in, sets things up for a second, says port listening disabled once it calls unlisten, and then we press return to continue if we want to. There we go. That's all we need right there. So now that we've got the firmware part of this built, we can build the Atari side of this. And you can see in the make file for the Atari side of this, you can see a whole series of commands which take and build each tool, go in and make each one, bundle it all up into an ATR file, and then throw it into the dist directory. So with that, we'll go ahead and make dist. And you can see right here, it's using CL65, which is the combination compiler linker in CC65, to build all of the binaries. If you were to go into each directory inside of each one of these, you would see a COM file sitting inside of here. So here we go. This is good. Bam. Grab everything together. Then we subsequently fconfig. Okay, grab all of this stuff. Put this all here. Bam. Put it all into our FNC tools ATR. And then I can copy that somewhere to test it. In this case, I will literally copy it directly over onto my TNFS server. And you can see I've got a whole stack of files here. In fact, let me do a little house cleaning right there and get rid of that because I'm done testing that. And we can see a whole bunch of stuff that I'm basically going back and forth on. This is the Raspberry Pi that you guys have seen earlier that's running TNFSD for me, specifically for my Atari. So, got this, it's ready to go. Let's test it out a little bit. With that, we can go ahead, keep this open here, and I'm going to bring up pardon that. I'm going to bring up my Atari. Okay. And I'm going to eject those. I'm going to bring in some DOS disks. For the first test here, we'll actually use DOS 2.5 just to show that it's working here. And then we'll take and load that FNC tools ATR that I just pulled over. Again, read only, because I just want to read it. And if we go ahead and mount it, go ahead and look on drive 2, and look at that. We have unlisten.com and unlisten.com. I still need to take and make a documentation page for that. But if we go ahead now, you'll notice that if I try, let's look at fconfig. And we can see our host name right here, and we can see our IP address. We can use either one of those to talk to the FujiNet. No problem. If I were, for example, to talk to, if I were to do, for example, use netcat to talk to Espressif at any particular port number here, you'll find that it will time out because there's nothing on the other side here. Trying, and then connection refused. You can see that that's not happening. But if I go ahead and load our listen here, you can see since this is running under a DOS 2 operating system, we have the opportunity to set a particular port. Okay, again, DOS 2, press return to continue. And since this is loaded up high enough in DOS 2, it actually just drops me right back to the menu. it doesn't have to load the DUP again. Now if I go ahead and connect in, you'll actually see that we're now connected to Espressive. It hasn't accepted the connection yet, but it has actually taken and opened up a listening socket. So it grabs the connection, says it's connected. The program still has to accept the connection, which for the modem is as simple as doing an ATA, sending an ATA to accept the connection. And then you can do communication back and forth against it. Conversely, if I run unlisten to unlisten, make sure it's on the right drive, you can see immediately port listening disabled, the connection is dropped. There we go. Conversely, I'll do this just as a counterpoint here. We'll do this from a command line operating system. For that, we will actually take and let's go ahead and we'll just do it from the config. So I'll hit the reset button here. Reboot. And we will go ahead and pick up a copy of Sparta-DOS 3.2D just for the sake of it. You can see our command line operating system here. We see our FNC tools. Now if I run unlisten, you can see that it says, oh, unlisten, give me a port number on the command line. And if I do that, oh, looks like we might actually have a bug there. Let's see if I can fix that. Let me see here. Let's see if I can fix that real quick. Port is less than 1. Interesting. I think I see the issue here. I'm not actually setting it. So let's go ahead, we rebuild that. And one of the nice things, because I actually have this mounted read-only, I can literally just take and copy this directly in place. Since the disk is being written out exactly the same way, I will actually literally take and just copy this directly in. And if I do the same thing now, unlisten, and we can see that the listening port is now active. Again, we'll go ahead. We can see that it's now active, no problem. And there we go. Boom. Bob's your uncle. So, I hope this has been a good demonstration showing what's actually possible here, how easy it is to take and add bits and pieces to FujiNet, how those bits and pieces can either be exposed through SIO, not just through the CIO handler, but through the SIO handler if it makes sense to do so, and how easy it is to actually communicate and control the FujiNet through SIO. So, until next time, guys, have fun.